This video is going to be a technical tutorial where we create a customizable video filter using Python and OpenCV for computer vision. In this case, we're going to be tracking our face and adding a mustache to it using our own custom code you can use for a Zoom filter or Hangouts, Teams, whatever other application. You can also use it on recordings and create your own resulting recordings. My last couple projects, I made a face-controlled keyboard and then a pants filter for Zoom, and I got a lot of questions and requests and suggestions for other modifications or other filters that could be created that way. The easiest way without any coding is obviously Snap. You can use Snapchat filters. They have a studio and you can also do some coding in there. But we're going to go completely from scratch and use MediaPipe for landmark tracking. In this case, we're using a lot of details of the face, but it also has full body and hand position tracking as well. So I'm going to be committing everything in this project along the way. I've just created a very simple getIgnore, but to start out, let's call this filter.py and go out to MediaPipe to see what we have available and copy out some example code. So you can see they support a number of languages and platforms, and of their solutions, this is a lot of different packages that can do some helpful things when it comes to computer vision and tracking. Holistic is a little bit of everything if you wanted full body plus face details plus hands. In this case, we're just using face mesh, but the ideas are very similar in terms of how you would code things around this. Each of these dots is a landmark. That's a XYZ position that it's estimating for a specific point on the face that it's found through some image. So if I scroll down a bit, I'll get to their API. These are the default values that are set, and then their example code for face tracking. So I'm just going to copy this in wholesale to start. Let's make a few little changes. So this has for images as well as video. In this case, we just want to use webcam. If you're only looking for one face in the frame, you can keep that. Refine landmarks gives you a little more detail on the mouth and the eyes or the irises tracking. These are also set to the default values just to let you know they're there, but if you're having a hard time, maybe there's not enough contrast in the image finding a face, or you're finding too many faces where you shouldn't, you might want to try modifying those around. And if we couldn't find the frame, we actually just want to break out something went wrong. This is a little wonky, but what's happening here is just some boilerplate that we'll need for optimization each time. We're making the image unwritable and changing the color space so that face mesh can process it. And then we're changing things back so we can display it properly. And then we draw in our annotations. So this will draw tessellations for connecting all of those points that we just saw with a set of lines. Contours around the whole face, eyes and mouth, and iris tracking. And then we just want to flip it around for selfie view. And we can hit escape on the image to escape out of the running loop. So let's try that much out. One other change I need to make. This has defaulted to 0, and so this is the device number. In this case, I happen to know it's 2 from my webcam. I've got a number of virtual cameras set up. If you're using an external camera, it might be something different as well. Or this could even point to a file. So I'll just write in a quick note. Depends on device input. And that should actually read from my webcam now. There we go. Tracking my face around. You can see really that we're just going to be looking at these few points, but wanted to show what's available to us there. I'll commit that really quickly. And now we can get rid of a lot of this since we're not going to be drawing in all those annotations. So let's clean this up a little bit. Instead of doing all of that, what we want to do is get the face XYZ coordinates of all of those landmarks. So that's going to be out of this attribute called landmark. And then we can draw something on our image using that face. So I'm going to create this draw function. And we'll modify the image in place, and then we'll display it with IamShow down here. Just to start out, let's print out what we've got. That'll be very big. So let's actually just get a single point on our face to start out. So to find what that point is, everything is hacked. If I go out to one of the other existing projects, I don't remember where I got this. I should remake it because it's very difficult to read these tiny numbers. But if you zoom out and scroll around, you'll see this is the flattened canonical face with each of those numbers, each of those landmarks numbered. So let's start out with just this middle point between my nose and my upper lip. This is 164. So this giant face array, we'll call it face at 164. It's going to be my lip middle. So let's see what that gets out. Oops. There we go. We can see as I'm moving around, we've got those XYZ positions of that single point. So just for testing, let's draw a point. Let's draw a circle where that point is. So we saw that that was some fractional number. We need to convert that, to normalize that to the size of the image itself. We're going to do that for a number of different points. So let's make a helper function of get the coordinates from some XYZ point, get the pixel placement of that point on the image itself. And we just want the X and Y values. We can take image.shape and get the width. So this is kind of like calling length on an array here. We're just saying how many X pixels across is it, which is index 1. And we can multiply that by the X value of that point. This is a pixel, so we need an integer. We don't want fractional pixels. And then we could do the same thing for Y. That's just at index 0. What is the height? How many rows are in this matrix here? Then we actually have to return it. Now that we can convert that, we can get our XY from get coordinates of that lip on the image. And then we can draw something there. So I'm going to draw a circle on the image. I don't remember the exact syntax, so let's just Google it. Go to the official docs. All right, on the image, centered at some point, XY. Believe this is a radius, a color, and a thickness. So we could just say 10. Color is, this is blue, green, red. So this should be a red, entirely red circle of thickness 2. So we're just tracking the point, drawing something where it should be. There we go. Now this is not going to change. It'll be a width of, or a radius of 10 no matter what. but it is tracking appropriately. And if I hide my face, then it comes back once I recognize it's the face again. Great. Let's just save those changes. And now, let's actually draw a mustache. So I'm going to go out and find a mustache. Sure. This should work fine for our purposes. Now it does have a white background here, so we will have to really quickly this won't be perfect, but we're not making fine art. Let's throw this mustache in there. Yeah. Oops, that wasn't the right one. It's this guy. Yeah, and we should crop that so that we have the proper size that we're working with. No need to draw on all those other pixels. Command K, and I've got my mustache in here. Great. Now, tracking and overlaying one image on top of another or one shape on top of an image can get really complicated really quickly. We're going to keep things relatively simple here. For a first pass, let's just hard code in the size of the mustache, and then we can resize it with our face a bit. We won't handle every possible angle and so forth, but just as a start, we can, let's say, get a width and height, or rather, let's set one of about something like that. Hopefully that's not too huge. And now what we need to do is get some sort of bounding box that matches, well, actually we need to do one other thing, which is resize and read in that file. And then we're going to get a bounding box based on that file and this size that we're working with. So we can use imread. And we're going to need to pass in an option here of imread unchanged. If we didn't pass this in, we would end up with a big white background and a rectangle to work with regardless. We don't want to change that fourth channel of alpha, that transparency, because we want to seamlessly combine these two images. So now that we've read that in, let's throw this up top, and we're going to resize this as well. Oops. And I believe that takes in a width and a height. So we've now sized it appropriately to our currently hard-coded width and height, but we'll eventually get those from other landmarks here. Now that we've resized it, we can get that bounding box I mentioned. So we'll have some sort of minimum, maximum, y, and x. And we can do that. These are essentially our center point, x and y. So we can take our y and just get rid of half of the height. This is a pixel value, so we want an integer. For the max x, we just add half the height, or max y, rather. And we can do the same for x. But with the width. Alright, so now we've got the four corners, essentially, that we're running through, going to run through the array across the entire image for this zone, and overlay the stash image on top of it. Now this gets a little tricky mainly because we want to keep that transparency. And so to do that, we're going to get this alpha transparency channel first and turn that into a normalized 0 to 1 proportion. So we're saying get all of the color values for the stash, and for just that alpha transparency, we're going to use that as sort of a fractional value to add one image on top of another. So we'll also need the inverse of alpha, just 1 minus that. And now we can loop over all of our color channels. So those are 0, 1, 2, red, green, and blue, or blue, green, and red. And for each of those, we get our image at that zone. So again, we're going for rows and columns. Our X and Y are sort of switched. That always feels a little unnatural to me. And we're going to assign it to the relative weighted alpha value of the stash and the original image. So I take the alpha inverse and add that amount of the image back on top for that same range. All right, let's try that out. Looking pretty good. I don't think I need more mustache, but you'll also notice it doesn't resize with me, so we're going to fix that. We're also going to fix how it seems to sort of come off my face because it's just hovering at this one point. Now what we won't handle yet is any sort of tilt, because then you'd need to skew the image, but we can get a little bit better than that with minimal additional work. So how are we going to do this? We need to get a few more points on my face. We'll need to get a left and rightmost in order to track better how to scale the mustache on each side. We're also going to need some sort of relative height here as well. If you think about it, we really need the mustache in parts, and so for ease of coding this up, we're going to do 2 halves. But we want one half to grow and the other to shrink relative to how we're tilting our face side to side. So let's make a half stash. Just open this guy up and crop him in half. Close enough. And now let's get a few more points here. So we've got lip mid. Let's get our left and our right. Let's say 322 and the matching 92. So 322 is on the left. We're looking at this face facing us. And 92 on the right. While we're at it, let's add in a lip upper and lower for the height. So we started at 164, we've got 2 above and 0 below as roughly our mustache range there. All right. And now we don't just have a single X and Y. We're going to get a few different points there. So rather than just mid, let's get our left and our right coordinates. And then for the upper and lower, we don't really care about the X values there. We already have those. But we can call this Y upper, our lip upper, and Y lower for lower. So our function's returning that XY, but we can throw out that first value when we're just looking at the height there. Okay. We can get rid of that. We'll do a bit more resizing, and we're going to apply this twice for each half of the stash. So let's dry that up and write a function. We'll call this add half stash. And that's going to take in some bounding box, so that min and max X and Y. It needs the stash itself, and it needs the image to apply it to. It's just going to apply that in place. Rather than a width and a height, we're just going to take the difference there. I believe the rest should be the same. Yep. Alright, so let's, now that we've read this in, apply our leftmost stash first. So to do that, let me think about this a second. We need to add the half stash for our X middle and then our X left. So this again feels a little backward, but X left, the left side of the face, is actually rightmost on our screen. So it's the larger value, and we want positive values to, a positive difference to be left. And same thing with Y upper and lower. So our upper is our minimum value, our lower is lower on the screen, unless you're upside down in front of your webcam, and then things will break. So we could take absolute values and find minimums and maximums and so forth if we really wanted to make sure, independent of someone's orientation, we could handle that. But this should be fine as an initial proof of concept. Now we just want to add in the other half of it. So we can use that same flip and flip this around the vertical axis. And now X right is our minimum and mid is our maximum across the X. Our larger value is the middle. Upper lower still the same. Should be all set there. Alright, so ended up a little squashed, but it is now resizing with me, and it's somewhat believably turning with me as well. As I mentioned, we didn't handle side-to-side tilt. You would have to do some sort of rotation matrix and then squash the image, figure out the details of sizing in terms of overlaying it, so that will be a little bit trickier. I'll commit this last piece, and feel free to have fun with making your own modifications. The other projects also include a couple examples of things like creating a recording, if you wanted to record your output to share it later, or using other devices as input. Lots of other things you could do for passing in command line arguments, make it a little bit easier of a utility to use. Actually, one last thing we could do, we can clean this up since we didn't use most of these helpers. If I just replace that down here, I think that should still be fine. There we go. Since we're not doing all of that annotation, ended up with a little over 60 lines for some pretty good rudimentary face tracking and adding to an image. The pants filter also shows using pyvirtualcam, so you can pipe out to a virtual camera and use that in Zoom or wherever else. So if that's your intended use case, there are just a few more lines and another dependency there. I should have mentioned this at the start, but you obviously will need to pip install OpenCV, OpenCV2, and MediaPipe as well to get started. One last note, if you're just starting out in coding, please don't let this get you discouraged. I've been coding for decades. This went relatively smoothly, and I've written very similar programs probably half a dozen times in the recent past. So coding doesn't normally look like this from scratch, but it's not very interesting to sit there and watch someone debug a simple syntax error for half an hour repeatedly, which I have done for many of these similar projects. So hopefully this was a useful starting point for many folks, and I'd love to see what you create. Thanks so much. Two last things that I thought of that I wanted to show really quickly. Since this was billed as a filter you can use with Zoom or some other output, I want to show using pyvirtualcam, since it's just a few lines of code. So if I import that, down here, before we open up this capture, we can grab the first frame, read that in the same way, and we're going to get the width and height of our video frame in order to set up our camera there. So now we can create a camera with a width of that number of X pixels, height similarly, frame 1, shape 0. We can also choose a frames per second. We'll call that as cam. We can indent all of that. We've now created a camera. Once we've drawn onto the image, we can then send that image to our camera and tell our camera to sleep until the next frame. And this is almost everything we need. However, if I just try that out, you can see within Zoom I've chosen my OBS virtual camera, and I'm this lovely shade of blue. So we need to convert the color space. We can do that similarly to what we did before, but we use CVT color of the image, and we want to go back to standard red, green, blue. Let's double check that. So my preview shows up this weird blue, but we're all set here. I created this virtual camera just by downloading OBS and starting a virtual camera, and then we can end that meeting. And then that shows up automatically for pyvirtualcam as the first selected device. Very last thing I wanted to show quickly was if you happen to be installing things globally like I tend to do instead of in a virtual environment like you should, you can use pipreqs to generate for your any files in the current directory or a given directory a requirements file. Great, so that's everything you need outside of the standard library. I'll commit that, write up a quick README, but hopefully this is enough to get you started with your own video filter adventures. Thanks so much.